6 we are going to create a graph out of data in the CSV file. Then we are going to apply triangle count, page rank algorithms on the graph, label propagation algorithm and BFS algorithms on the graph, and find shortest path with respect to landmarks. Finally, we are going to save the graph to a file. Let us move on to the code. We are reading the trips data from a CSV file into the trips_df. We are giving the header, and the format of the file is CSV, and the file name is given over here. Trips.csv contains the data about the trips, the trip ID, the source and the destination, etc. The next file that we are loading is the stations data.csv, and again we are giving the header, and the file format is CSV, and this data contains about the stations, each station and its properties, and we are loading it into station_df. We are printing the schema. As you all can see, this is the schema of the trips table, and this is the schema of the stations. Then we are creating a temporary view named trips out of trips.df, and temporary view stations out of stations.df, so that we can apply SQL queries on the views. The first query that I'm applying is select star from stations, and the output I'm storing into the station. Select star from trips, and the output I'm storing it into the trips. I'm renaming the station vertices with the column name. I'm renaming it to ID, and in the trips I'm renaming the start station to source and the end station to the destination, and storing it in station vertices and trip edges. Now with the vertices and the edges, I'm creating a graph, and as we know that each station would be a vertex, and various trips between the stations would be the edges. So I'm giving the vertices, station vertices and the trip edges, and I'm creating a graph out of it and naming it as the station graph. I'm printing the total vertices count and the distinct vertices count, the total edges count and the distinct edges count, and the original data which is present over here. I'm counting from here the total number of edges, trips.count, and the count is displayed over here. This is the data of the trips station table. This is the data of the trips table, and the next thing, I've displayed the vertices and the edges. And the next thing I'm displaying is the triangle count. But before proceeding to the triangle count, the total number of stations, distinct stations, trips and distinct trips, and the trips in the original data is given over here. Later I've even displayed the vertices which showed the station table, and the edges which showed the trips table. And then I'm performing the triangle count. It would be giving the triangle count at each vertex, the number of triangles at each vertex, and I'm displaying the ID, vertex ID, and the count at it, and this has been the output. And I'm moving on to the next query. It is the shortest part. The sequence of locations I have given is Japantown and Santa Clara counties, the big center. So it would be generating the shortest paths, and I'm displaying the shortest path, and it is seen over here. Shortest path, Japantown to Santa Clara. And the next thing algorithm is the page rank algorithm. It would be giving rank to the vertices depending on the weighted graphs, how more the vertex can be visited, and the adjacent rank of the adjacent vertices. So I'm giving the reset probability over here, the randomness as 0.15, which vertex can be selected to start the random walk. The randomness I'm giving it as 0.15 and the tolerance value as 0.01. The change from one iteration to the next iteration, if it is less than this, then the algorithm will terminate and return the results. I have run the page rank algorithm and now I'm showing the vertices and the edges. So the highest page rank is for the MLK library vertex, and similarly the rest of the vertices and its page rank, and the weight of the edges can be seen over here, which edges carry more weight. This is about the page rank. Then moving on to the next algorithm, I'm writing the vertices and the edges to the files, and as we can see the files are generated over here. This is the edges, and similarly even vertices has been generated. Moving on to the bonus questions, the label propagation and the BFS algorithm. I'm running the BFS label propagation to find out the communities in the network and the maximum iterations that we can do in the graph. I have given as 5 and I'm running it. And I'm doing the lpa.show. I'm selecting the ID label and I'm displaying it. So this is the label propagation output. It has been giving labels to each of the stations, and as we can see, the label for these two stations has been the same, so they are grouped into a community. Moving on to the next algorithm, the BFS algorithm. I'm starting from Japantown and I'm doing the BFS approach with dog count less than 50 and I'm displaying it. So let me show the output. This is about the label propagation and here is the output of the BFS. So it's starting from Japantown and it's showing the running it in the BFS approach. As we can see, the values are changing. This is all about the ICP6.